Hello everyone, my name is Akshit Khandelwal and I am a third year student studying engineering in computer sciences at Bennett University. I'm looking forward to discussing my topic with you today, which is gait analysis for biometric verification as a part of my current semester subject seminar on special topic in emerging areas. So let's begin. An accurate biometric system which can be used in public spaces for better security is the one thing required by our society right now. One of the major reasons for bad result in these type of approaches is the bad footage quality obtained from the CCTV camera and various other factors. There are many types of biometric features for a person's identity recognition like fingerprints, retina scan, voice recognition, hand geometry, etc. There is also a very interesting feature known as gait, which every human being possesses. Every human being has a unique kind of gait movement, therefore, it can be considered as an important key for biometric analysis. Through this presentation, we will try to understand identifying a person through his gait movement. One more good thing about gait analysis is that it tells whether the person who is passing by is suffering from Alzheimer or not from their gait movement. Because of these specialities, this biometric feature can be used in various fields like security and healthcare. We have heard this term gait in the introduction, but what actually gait is? So, gait is nothing but the locomotion achieved through the movement of human limbs. Gait analysis is a type of biometric analysis which analyzes a person's movement. But why are we considering gait analysis for our verification? This question might arise in your mind, and like, what is the problem with the previous available biometric verification methods? Let's look into that. In case of fingerprint retina scan, we need a person to cooperate and take their data for analysis. This kind of approach sometimes causes some kind of inconvenience. But in case of gait analysis, this biometric analysis can be done from a distance with the cooperation of the person on whom this is going to be done, as well as causing less inconvenience. Moreover, recognition of gait features do not get affected by some external factors like walking speed of the person, the frame setting of the device used, the quality of the camera used for capturing the body movements, the camera viewing angle, as well as the type of clothes the person is wearing, whether or not they are carrying anything with them or not. Okay, so there are two ways to capture gait features of a person. Firstly, you can capture it in the form of images, and secondly, can capture it in the form of videos. Now, what will be our problem definition? Let's look into that. It is basically to design and develop a robust and accurate biometric system which can be used in public spaces for increased social security and crime prevention. This should be modular. This system should be modular and dynamic as well, so that it can be easily integrated with various security systems. And the system should work on poor quality and long distance video footage as well. By this this can be easily achieved using gait analysis. Now the next slide will be about the motivation behind doing this presentation. Since we all know that gait is a biometric feature which can easily be analyzed and is unique for every human being, this fact that every person has a unique gait movement itself motivated me for taking this as my semester presentation topic. And there are many ways a person can be identified. Still, many times mistake happens because of which people need to pay the consequences. If we try to analyze this feature precisely, then it can literally help in creating more secure systems in the coming time, and hence helping us in creating a better future. Now let's discuss about the methodology. Here we have four parts: problem formulation, set pooling, horizontal pyramid pooling and mapping, multi-layer global pipeline. We'll discuss about them one by one in the upcoming slides. So, problem formulation. Here we first formulate our concept of using gate as a set. Let's assume we have a database of n people with identification by I, where I is like up to 1 to n. Then we need to assume that each person gait silhouettes are subject to a distribution of pi, which is related only to its identity. Thus, we can consider all the silhouettes in one or more sequences of a person are a set of n silhouettes, which is xi given in the slide. When we use this assumption, we can handle gait recognition task through three major steps formulated as Fi is equals to Hg Fi, which is mentioned over there, in which where F is convolutional neural network whose basic aim is to extract frame level features from each of the gait silhouettes. G is used to map a set of frame level features to set level feature, thus it being a permutation invariant function which implements set pooling. H is a function whose job is to learn the discriminative representation of pi from the set level features, and it is implemented using horizontal pyramid mapping, which we will see further. The input tensor with the set dimension, image height width dimension, and image channel dimension make it a four-dimensional tensor. Now let's look at the set pooling. So set pooling is basically used to aggregate the gate information of all the elements in a gate set, which is mainly defined as z equals to gv, where z being the set level features and v being the frame level features. Okay, this operation is applied to keeping two major constraints in mind. First is whenever we take a set as an input, it has to be a permutation invariant function which is defined as below, which you can see, where pi being any permutation. And the second is that the function g should have the ability to take a set with varying arbitrary cardinality, as a person's gait silhouette can be arbitrary in a real life. Now, as you can see, there is one picture which represents the whole gate set architecture. Moving on to the horizontal pyramid pooling and mapping, the discriminative parts vary for every image. Okay, due to which we used horizontal pyramid pooling because it can fix it. It has four scales which allows it to help the deep network focuses on features varying size to gather the global and local information. We also propose an improvement in HPP which helps it to adapt better for gait recognition. In place of applying a 1 cross 1 convolutional layer, once the pooling is done, we apply independent fully connected layers for each feature that is pooled and mapped into space. We name this method horizontal pyramid pooling. Moving on, here you can see the diagram which represents horizontal pyramid pooling and mapping. Now, the multi-layer global pipeline. There are different respective fields in different layers of convolutional neural network CNN, which becomes larger as we go deeper into the layer. Therefore, the pixels residing inside the feature maps of a shallow layer which actually focuses on local and fine-grained information, whereas those which exist in deeper layer will focus on more global and coarse-grained information. As we know from the explanation of set pooling, there is only one SP on the last layer of the network. Therefore, we need to collect various level set informations, and we propose a multi-layer global pipeline for the same. Its structure is analogous to the convolutional neural network in the main pipeline, but the set level features extracted from various layers are added to it. The final features generated by this will be mapped into the same number of features as previous by the HPM. Now, the training and the testing phase. The output of the complete network is 2 multiplied by the summation of 2 raised to the power s minus 1 features with a dimension equal to d. All the features among different samples are to be used to calculate their loss. We have used binary cross entropy as a loss function alongside Adam optimizer. A batch size of p cross k is taken and the batch is sampled from the training set where p denotes the total number of persons, and K is the number of training samples for each person. And in the testing phase, given a new set Q, our major goal is to get all the sets with the same identity inside the identity gallery function G. The new set is first put into gate set net to generate multi-scale features. Then all the features are concatenated to generate a final representation. Then the final representation is compared to every representation in the gallery set to calculate the recognition matrix. We use Euclidean distance for the same. As we move on further, now we shall see what are the hardware and the software requirements which are used for doing the gait analysis. The hardware requirements include cameras. The project is based on shooting subjects with HD cameras from 10 directions, all based on 18-degree differences focused on the subjects. And the computer requirements are NVIDIA GeForce GTX 1060 GPUs or equivalent for almost real-time prediction. And the software requirements include Python 3, GPU, CUDA bindings, and TensorFlow, OpenCV, Keras. Now, moving further, this is basically what the camera setup visualization will look like. Moving on, the implementation plan. In this, we use the Cassia B dataset, which is very popular gate dataset that we are going to use. It's basically 124 individuals with three walking conditions, which are normal walking, walking with bag, and walking while wearing a coat or a blazer, something like that, and 11 different views. The official data has not defined any specific division of data. Thus, we train our model in three different settings, namely small sample testing, which is like 24 for training and 100 for testing, medium sample testing, which is 62 for training and 62 for testing, and finally the large sample testing, which is 74 for training and 50 for testing. Now, moving on, the image pre-processing and feature extraction. In this, we have first pre-processed the image, which means the images in the original datasets are divided into folders, with each folder representing a particular individual and the subfolder representing the walking conditions of the individual. For simplicity, we need to rearrange these pictures in a single folder with their names encoded of all the above mentioned details. Now, one more reason behind performing this step is to find the contour of each image and then crop that particular section of that image, discarding the rest. Contours are basically the line joining all the points alongside the boundary of the image that have nearly the same intensity. Now, in the second step is in this is pickling the images. Pickling is basically used to serialize or deserialize a Python object. Now, this serialized data can be used to reconstruct the image in any other Python script. And you can also see there is one image which represents a complete gate cycle from starting to end. By this, we have almost reached the end of our presentation in which we are discussing the result, which is like for calculating the accuracy of our model on the test set, we process the target image through gate set to get required representation. Each set in the gallery is also processed similarly, and the representations are then compared using Euclidean distance. If the distance is below the threshold level, it is considered to be identical to that set. We then apply rank 1 accuracy to evaluate model performance. We test model accuracy on different dataset sizes, namely small sample training, medium sample training, and large sample training. We use three different scenarios of gait sequence of walking conditions, like normal, with a bag, and with the subject wearing an overcoat. Now, moving on, the conclusions and future work will include the increased robustness of this approach make it a great candidate for potential practical applications in both forensic surveillance by policing and counterintelligence organization at various levels. Secondly, the extreme robustness allows for an high secure biometric application which would be harder to fool than fingerprint or retinal scan based systems. Further optimization can be explored to improve model performance with complex or lesser detailed data, such as low resolution video sequences or those corrupted by noise also. And by this, I would like to end my presentation, and I hope you all like it, and you got to know about what is gate analysis, why like it can be used for biometric verification, how can we do it, different methodologies, and everything. So thank you for your attention. Goodbye.